Hello guys, welcome to another video. Today we are starting 1.3 electron configuration, but before you need to understand emission spectra. So following the IBC levels, we have 1.31 and 1.32 emission spectra. So you will qualitatively describe the relationship between color, wavelength, frequency, and energy across the electromagnetic spectrum, and you will describe emission spectrum of the hydrogen atom, including the relationship between the lines and energy transition to the first, second, and third energy levels. So let's start it. Okay, guys, this topic start always with a test. If you are in chemistry and you have in your chemistry lesson and you have a laboratory, this is one of the experiments that you are running. So this is the flame test, and the idea is that in this flame test, you will identify different colors produced by or emitted by the different elements. So if you see here, we have calcium, potassium, and copper. In this video, there is just could be a nichrome wire. In the one we put a salt of the metal is illustrated here. So here we have in the first one, we have sodium. When we put a salt of sodium and we get closer to the flame, here we will have a particular color. In this case is yellow. If you do the same as you put a salt of potassium, this is what you're gonna get. This is the color of potassium. So this is like a purple, a bluish color. And here you have the color of copper, a copper salt next to the flame, and atoms are excited. So what is happening here and what is the phenomena? So when you heat up this solution fired close to the copper sulfate, close to the flame, so in this case, let's talk about the copper sulfate salt, for example. The most important is that they are copper atoms, and in this tiny example. So here we have, by the way, this wire is used because it's inert to the flame and it cannot oxidize and it won't reflect another color. That's why we say that this will be the color of copper. Okay, let's continue here and what is happening. Why do they have different colors in the first place? So if you imagine the atom, simplest atom with, let's put 3 energy levels. This is just an atom with 3 energy levels. So we say that this is the nuclei of the atom, and then we have 3 different energy levels. Let's imagine that we have the electrons. Let's put them in yellow, could be. So we have one electron in the first energy level. Let's focus in this electron. So in that moment, the wire with the copper sulfate, we are exciting some atoms. And in the moment that we excite the atoms, the electrons jump to a higher energy level. So in that case, this electron is jumping to, let's say, the third energy level. Different energy levels is just to show you in this example. So when the atom is absorbing energy, electrons are jumping to a higher energy level, but instantaneously this energy is losing that energy. The electron will fall down to the ground state or to the basal state. In that moment, when the electron is falling down, there is a release of energy. Okay, so the atom will release an energy in the moment when the electron is falling down to a lower energy level or to basal state. In that moment, and this particular atom is emitting in a particular frequency, in a particular wavelength. And because of that, is producing a different color, okay? So if you have an atom of copper, it will produce a different color than the atom of potassium and the different color of the atom of sodium. Why? Because atoms are different. The chemistry of the atoms are different. Atoms can have different energy levels. They can get excited and jump to a very different energy level, and they can fall down to the second or third or even first energy level. So because atoms are different, because there are many possibilities to get jumps and fall downs of electrons, that's why we will have different colors, many different colors across the periodic table. Okay, so, and this is an example, and this is just how we understand the emission of absorption of the atom. When it's absorbing, the electron is jumping to a higher energy level. The electron is falling down to the basal state, on the natural state. The atom is emitting energy, and in that moment is when it's releasing light in a particular frequency, a particular wavelength. Okay, so this is the explanation of this experiment. Okay, guys, now that we understood how atoms are absorbing and emitting energy, it's important to understand that atoms are emitting and absorbing energy in different frequencies. But before, we need to understand the electromagnetic radiation. The electromagnetic radiation is just a form of energy that travels through space as oscillating electric and magnetic field. Okay, so imagine that energy is traveling in the way of waves. Or what do we need to understand about the wave? So first one, here we have the wavelength. Here we have a wave. If you see, this is the movement of the wave, and this is how energy is traveling. Okay, it will travel in the x-axis and in the y-axis, but I will explain that in a moment. What is important is that you understand that energy is traveling as a wave. Okay, so this is the energy traveling. Now, this energy, it's important that we recognize that we have different wavelengths. Okay, certain energy is traveling with a different wavelength than another energy. For example, one atom is able to emit energy with a particular wavelength, and other atom is able to emit energy with a particular wavelength. The same as the atom is able to absorb energy and emit energy in that particular wave. What is the wavelength? The wavelength is just the distance between the crest and the crest. Okay, if you see, this is a complete wave, and that's why the wavelength is defined between one crest and another crest, because this is how we measure the waves. What do we need to understand here? Sometimes the wavelength is short, or sometimes the wavelength is long, and depending of how long or how short is the wavelength, there is something called frequency. How can we define frequency? Imagine that we have this wavelength like this, but also we have a wavelength like this. Something that also we need to understand is that energy is traveling only in one specific speed. The speed of light is 3.0 times 10 to the power of 8 meters. We will talk about this over a second. But now, if you see, there is a point between crest and crest, because the energy is traveling, is oscillating all the time. We call frequency to the number of waves that travels in a particular point. So we put this point A, and let's say that the wavelength is traveling in this direction. If the wavelength is traveling in this direction, how many times we will have this point? We will get to point B, yeah? And then we go to point C, and then we go to point D. So you need to imagine that this wavelength is moving in this wave and is passing through A, B, C, and D. So the number of times that the whole wave is traveling over second is known as the frequency. So if you imagine here, there is a smaller wavelength. Let's say that this is the point. Because it's shorter and is traveling the same speed of light, there will be more times that this energy will travel and will pass through the same point. So in that case, we say that this one over here will have a big wavelength but a shorter frequency, this one, and this one will have a shorter frequency and a shorter wavelength. You see? So because we will have more waves passing through this point in 1 second, meaning that we will have more frequency, and here we have less times passing at this point. So we need to imagine the waves and need to imagine that both are in the same speed. Okay. Now, how is this related with our real life? So we talked about visible light, which is kind of radiation. For example, the light that we see in our lamps or that we see from the sun is visible light, is one of these radiations. We have the radio waves, the one that are capturing our cell phones. This is another kind of wavelength. Here we have microwaves, the Wi-Fi. Infrared radiation is the remote control, and the UV light and the X-rays. Okay, so we have different kind of energies, different kind of radiation traveling in our daily life. Okay, they will have different frequency, they will have different wavelength. For that reason, also will have different energy.